Now we have to discuss chapter of the electricity in the 10th syllabus. So we have to discuss in the previous lecture in the series combination of the resistors. Now we have to discuss the resistors in parallel. So now we have to draw the diagram first. We have three resistors. This is the resistor 1 and this is the resistor 2 and this is the resistor 3. There are three resistors which are connected in parallel combination. This is the battery, so this is connected to the battery. All of the three resistors are connected to a DC supply. This is the DC supply of the voltage source V, and this is the resistor R1, this is the resistor R2, and this is the resistor of R3. This is the supply, DC supply. Here we have to consider this is the negative, which is lower potential, and this is the higher potential. Current is always traveling from higher potential to lower potential. It means current is flowing on the positive terminal of the DC supply. Now the current is flowing here, and here is current is flowing, and in this way the current is moving from here to here. Now this current is divided in three parts because there are the three branches. Here the first branch is R1, second branch is R2, and third branch is R3. And the current is divided here in the three parts. The first part of the current is going from the R1 resistor, and this is known as I1. And the current I2 is moving from R2 resistor, and the current is moving from this resistor is I. And the current I3 is going from 3 resistor, and R3 is passes to the I3 current. And this current is passing here, and this current is passing here, and this current is passing here. Here we see that I1 is coming from here, I2 is coming from here, and I3 is coming from here. Now the combination of the current I1 plus I2 plus I3 and the net current will become VI, because here junction law is followed. I is equal to I1 plus I2 plus I3. Actually this is the Kirchhoff junction law, Kirchhoff current law. Here the current is divided into three parts. Here total current is I1 is distributed here, I2 is distributed here, and I3 is distributed here. The net current will becomes I1 plus I2 plus I3. And we are interested to know, we remove this circuits by another circuit. Means we remove all the three resistors, and the resistor is applicable like that if V is applied only a single resistor. And same sources of battery, same sources of a DC supply. This DC supply is source of V, and this is the resistance of R. Now V, the I current is drawn from here, and current is moving like that current. Here we see that V is equal to I into R. Ohm's law. From the Ohm's law, we have to written V is equal to I is the current moving from here. This is the current I and moving from here to here, and voltage difference is equal to I into resistance. And here we see that this is the positive terminal of the battery, and now we can assume this is a zero potential and this is a V potential, because the potential difference is V. If we assume that this is 0 and this is V, what is the difference between them? This is V and V minus 0. The potential difference is V. So now we can see that this is attached to the V potential, and this is the V, this is the V, and here we can see the potential difference is also V, because connecting wires has no potential drop. Now we can here see this is the 0 potential, this is the 0 potential, and this is the 0 potential. And here we can see that here potential is V and here potential is 0. If we see that the R1 resistor is passes through from this way, here the potential difference is V. This is the resistor R1, and here the potential difference is 0. What is the potential difference across the R1? Is V. For V minus 0 is V. Here we can see V is equal to I into R using by the resistor of R1. Here total potential drop V minus 0 is V. Current is in this branch is I1 and resistor is R1, and V is equal to I1 R1. Now we moving from here to here. Here is the potential drop V. Here is the potential drop of 0. We are crossing the resistance of R2 and we are applying V is equal to IR. Then V is equal to, the current is moving from R2 resistor is I2 and resistance value is R2. And again we have to see that if we are moving from R3 resistors, here the potential drop is V and here the potential drop is V, and we are moving from this path and applying the voltage formula V is equal to I3 into R3. There are the three equations we have to written here. We are using this formula, I is equal to I1 plus I2 plus I3. Now we can write the value of I. Here I is written as V divided by R. And from here I1 is written as V by R1. Here I2 is, this implies I2 is equal to V by R2 and I3 is equal to V by R3. Place the values of I1, I2 and I3 in these equations. Then I is equal to V by R1 plus V by R2 plus V by R. V is taking common from here, 1 by R1, 1 by R2 plus 1 by R. Now here V and V is cancelled out. Now 1 by R is equal to 1 by R1, 1 by R2 plus 1 by R. This is the formula which is applying in the parallel combinations. Here the important point is that, the first point is that if the resistors are connected in parallel combinations, here the only 3 resistors are connected. If n resistors are connected in parallel, then if n resistors are connected in parallel, then formula becomes 1 upon R is equal to 1 upon R1, 1 upon R2, 1 upon R3 plus 1 upon R. This is the formula we have to do first. Now another important result from here is that if we are seeing here, the value of current in each resistor will be different, but potential drop across each resistor is same in each cases. Here potential drop is same in each resistor. This is the important condition. If the resistors are connected in parallel conditions, then the potential drop will be same across each resistors. The another point we have to remember that current in each the resistor will be different. Here we write as current is different. Current is different in each resistance. Current is different in each resistance. This is the important fact we have to remember. And another important result we have to remember that if the 2 resistors are connected, because in the numericals generally 2 resistors are connected in parallel. Here we have to avoid the calculation purpose. Then we are using the direct trick here. If this is the resistor of R1 and this is the resistor of R2, if generally of the questions R1 and R2, there are the 2 resistors which are generally connected in the parallels, then we apply the important result R is equal to R1 R2 upon R1 plus R2. We are using this result because here the calculation is reduced and hence we are applying direct current resistance of R1.